Wishing good day for all. Here, the topic we are going to discuss about intermediate track chemistry will be helpful for your international entrance examination or competitive exam you are seriously preparing for. India level JE advanced and JE mains examination, which will be fetching for your IIT and NIT ranking, and also will be the technical domain. NEET chemistry for medical entrance examination across India. Telangana and Andhra Pradesh MCET examination for engineering stream will be helpful for the technical, your technical career. In addition to all these, if you are aspiring for any kind of government examinations, whatever the kind of exam it might be, there is a compulsory question paper will be there called general studies. So general studies included with so many dimensions of education. In that, general science will be the content where you can focus on the chemistry content as well. The topic we are discussing will be very much fetching for that kind of preparation. Let's enter into our today's session. Explain the name of following compounds as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. So according to that, you need to give the name for these many. All are said to be organic compounds only, and moreover, you can find chloro, bromo, and chloro again. So that here, 2 carbon chain with chloro, 3 carbon chain with bromo, 6-membered ring with a fluoro. In order to assign the name, there are certain regulations in accordance with the IUPAC protocol. Common names are provided. This is called ethyl chloride. As per the IUPAC norms, it is called chloroethane. The compound is regarded as chloroethane. And the second one is 3 carbon chain, where isopropyl bromide is the common name. Commonly, we can treat it as isopropyl bromide. As per the IUPAC, 2-bromopropane is the systematic nomenclature. And this is about cyclohexyl chloride. Cyclohexyl chloride will be the common name. Chlorocyclohexane will be the IUPAC name of the compound, right? So whatever, if you observe all these compounds, whatever functional group is there, that will be taken as a suffix, and whatever chain length is there, that can be taken, that alkyl chain is taken as the suffix, right? Chloroethane to bromopropane, chlorocyclohexane. This is the way we can answer IUPAC nomenclature of the given compounds. For question number 1, chloroethane, 2-bromopropane, chlorocyclohexane are the IUPAC naming. Move on to question number 2. This is collected from Cambridge Assessment International Education Platform. Methane burns in the oxygen to produce carbon dioxide and water. Whenever methane is the kind, why we are discussing this will be, it is more interesting. Methane is the kind of fuel we are using in the domestic purpose, industrial and aerospace purpose as well, right? Where can we find this? If you go with biogas, especially in the rural region, biogas plants will be available where we can take cow dung and also garbage collected from the kitchen waste and any kind of material which is of natural origin, waste from the natural origin can be collected and can be dumped inside a dark dome type of material where water will be mixed. Without oxygen, we are going to treat for the longer time, which is said to be absence of oxygen and designated as anaerobic process. Anaerobic decomposition, whenever any waste decomposed in the absence of oxygen, so that we will get the fuel called methane. That methane is a what sufficient and clean fuel for the domestic purpose or kitchen fuel. It will be especially in the rural region, because we can find cattle and so many kind of animal will be available, so that we can collect their excretes and they can be decomposed under anaerobic conditions, so that methane as an efficient fuel we can generate at our household purpose, right? So this is the way. And moreover, we have another kind of methane as a fuel in a CNG. CNG stands for compressed natural gas. That CNG is an efficient fuel in order to transport like railways, and even city buses are running with the CNG called Compressed natural gas. Natural gas is mainly composed of water, methane as well, right? So again, you can find methane as the main component over there. That CNG also used in the aerospace purpose as well, right? These many applications you can find for this kind of methane, right? So that the kind of question what we are discussing will be very much important regarding its application part. It will be right. So how it will become a fuel? Whenever you are burning, if it's releasing certain extent of energy, then only we can say it is a fuel, right? So that you are taking methane gas and added with oxygen subjected to combustion. Heating in the presence of oxygen is called what? Combustion process. Whenever methane combusted, the products evolved are carbon dioxide and water. This is the commonly available reaction, but they are asking for balanced equation. In order to get the balanced equation, methane can be binded with oxygen so that carbon dioxide water will be generated. So here, in order to get the balanced equation, law of conservation is required to be focused, right? Law of conservation is nothing but whatever extent of atoms are there left hand side, same extent of atom should be their right hand side. We neither loss or gain any atoms in the reactant side or product side. Whatever number of atoms are there in the reactant side exactly is equal to product side. That is called law of conservation. All right. So here, in order to get the balanced equation, we are taking methane. Methane is one carbon hydrocarbon. CH4 is the chemical formula. And you can combine with the 2 moles of oxygen. If you observe here, 2 moles of oxygen, it is a diatomic molecule like this. 2 moles are required for 1 mole of methane combustion. Why? So after getting products, you can clearly analyze why 2 moles are required, right? So this methane upon combustion will be turned into carbon dioxide, which is the oxidized product. Later on, whatever hydrogen is there, that also bonded with oxygen, so that water will be the another product. So let me count the number of atoms left, number of atoms right. Carbon. If you observe in the 2 reactants, only 1 carbon is there. Here also in the product side, 1 carbon is found. Then go with hydrogens. You can find 4 hydrogens in the left-handed side. Those many 4 hydrogens, if you are taking 2 a coefficient in front of water, so 4 hydrogens, again, they got balanced. Move on to oxygen. 2 moles of O2 are required. 2 moles of O2 are required. So for reactant side, here O2, that means 2 oxygens found in carbon dioxide and 2 oxygens found in 2 moles of water. So that 1 methane combines with 2 water, gives rise to carbon dioxide 1, and 2 water will be generated. Sorry. 1 methane, 2 oxygen gives rise to 1 carbon dioxide and 2 water will be generated. This is the balanced equation will be written, and that is available in the option number B. This is about law of conservation, and you can find equal number of atoms left and right hand side in the balanced equation. This is about what? Combustion of methane, right? For question number 2, option number B will be the correct answer. Move on to question number 3. This question number 3 is extracted from JEE Advanced 2021 question paper, paper 1. The total number of possible isomers for platinum NH3 taken for Cl2Br2. This is the complex of platinum you can find. How can we name this one? Tetra, amino, dichloro, platinum 4 bromide. This is the nomenclature, we can say IUPAC nomenclature for the given platinum complex. Let me repeat once again: tetramine, dichloro, platinum 4 bromide. So this is the way we can give the name for the compound, and they're asking for possible isomers. In order to write the possible isomers, first of all, we have to know what are the possible orientations. If you know the possible orientation, so that we can extract the possible isomers, right? Isomers are nothing but with the same formula, how many ways you can write this compound. So all these can be mentioned with the 6 possibilities. How many isomers you can write? 6 isomers are possible. Let's see how can we answer this one. So in a simple form, we can represent like this. Platinum NH3 taken 4, if chlorine is there inside, Cl2 is there inside and Br2 is there outside. inside, outside, there is a certain difference. Inside sphere is called coordination sphere. Outside sphere is called ionic sphere. Means whenever the same compound is placed in the water as such, so the entire complex will acquire a positive and bromide will acquire negative. This is the way. This is called coordination sphere. It won't be ionized a further extent. This is the kind of ion itself, its identity will be retained. Whenever this compound entirely added to water, the entire sphere will become positive. The square bracket will become positive, and whatever outside is called ionization sphere. Coordination sphere, ionization sphere. Ionization sphere, bromides will be converted into Br minus. This is the way you can represent, and these can be existing in two ways. How can you write two ways? One of the possibility will be cis, in either possibility will be trans. Cis denotes what? You can incline these two chloro on the same side. If same dimension two chloro are oriented, that is said to be cis. If two chloro in the opposite with respect to each other, that is called a trans. Two chloro in the coordination sphere can be written, can be oriented in either same side or opposite side, so that we can write a cis and trans. Okay. Second possibility will be, let me drag this bromo inside the sphere and pull the chloro outside the sphere. What happened? Platinum NH3 taken 4 ClBr, and outside the sphere as well, ClBr will be there. So within the coordination sphere, one chloro, one bromo is there. Outside the coordination sphere, we have chloro and bromo, right? So in this case, what you can write, chloro bromo on the same side will become a cis. Chloro bromo are opposite in direction is called a trans. This is the way, again the compound number 2 can exist in cis and trans, both the isomers. Move on to compound 3, where 2 bromo are inside, 2 chloro are outside. This is another possibility you can write, because in the same molecule we are not supposed to change number of atoms and nature of the atom. Only the thing is just we are making inner to outer, outer to inner. This is the kind of ionization isomerism. All these are said to be what? Ionization isomerism. We are making coordination sphere to ionization sphere and vice versa, right? So here 2 bromines are taken inside and 2 chloro are taken in the ionization sphere. That is exactly reciprocal to this kind of representation. So it is entirely reversed to the compound number 1. Again, 2 bromo can be either cis or trans, so that you can put 2 over here. Let me give all these compounds, all these complexes, we can say, all these complexes in the detailed structural geometry, right? So if you go for the compound number 1, where you can find platinum NH3 taken for Cl2Br2, right? Both the Cl2 are present, both the chlorides are present inside the coordination sphere. So that let me put platinum is the kind of complex where octahedral you can find. Octahedral denotes what? Central metal is accomplished with the set of 6 ligands in the octahedral sphere. Fine. And here 4 coordinates, 4 planar coordinates are denoted with NH3, 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 NH3. NH3 is the ligand, monodentate ligand, monodentate neutral ligand, we can say. And the chloro is inclined in the axial position. These two are called axial positions. Right angle is called axial, no? So that this chloro above side and this chloro below side, both are said to be anti with respect to each other. Both are anti. Anti means what? Opposite with respect to each other, which is designated as a trans one. And same can be written in another dimension also. How can we write? 2 chloro are taken in the equatorial position. Equatorial means what? You can put on the plane. So this is a plane, right? On this plane you can put 2 chloro, and all 4 NH3 are inclined in another direction, so that 2 chloro on the same side, so that this is said to be what? Cis. These two are possible cis trans isomers for what? First complex. Move on to second. The second complex, one of the chloro and bromo is present inside, in either chloro and bromo are present outside the sphere. They are inclined in the same manner. Chloro is taken in the axial and bromo is also taken in the axial. Both are anti with respect to each other, said to be trans. And chloro bromo are taken in the same direction, we can say equatorial position on the plane you can put over. And this is said to be cis kind of conformation, cis isomerism. Cis trans is a geometrical isomerism, we can say. And third possibility, platinum NH3 taken 4 remains as common for all the complexes, and another change what we made, 2 bromo are taken inside, 2 chloro are taken outside the sphere. In the case, 2 bromo are occupying the axial position. If this is the case, we can say anti-conformation, anti-orientation, and it is called a transgeomer, geometrical isomer. And 2 bromo on the equatorial planar position. This is said to be a cis1. So this is the way all possibilities can be mentioned with the cis and trans both, and all are said to be how they are interrelated with one another. All these three are interrelated one another by the ionization, by the isomerism called ionization isomerism. That's the reason why we can say coordination chemistry is more interesting, because we can find multiple possibilities and multiple applications as well. So many complexes you can find with the same compound, same metal, and so many catalytic activities found for them. So many colors are possible, so many kind of magnetic nature you can experience. That's the reason why d block elements and transition elements plays a vital role and important and interesting to learn about. Whenever you are learning about one concept, it will give a way for a next. That is the way extension for the learning will be continued if you pay attention for a moment, right? For question number 3, correct answer will be a 6. Move on to question number 4. Question number 4 is collected from JEE Advanced 2021 question paper. Paper 1, it will be the green colored produced in the borax bead test. Borax bead test of chromium 3 salt is due to, right? So borax bead test is the identification. This is the kind of what we can say qualitative analysis. Qualitative analysis means any compound is taken roughly without measuring the content, what is the amount it will be, how much volume it will be, without measuring, just you are taking the compound roughly and added with the drops of reagent, so that by changing the color, or else by getting the precipitate, or else by getting the effervescence of gas, or any kind of transformation, either visible or else chemical. So that kind of because of that transformation, you can identify what compound it is without measuring its volume or weight. That is said to be qualitative analysis. This is the kind of test what we are doing here is the part of that qualitative analysis in order to identify chromium salt here. That is called a borax bead test. Whenever borax bead test is performed in the chromium 3 salt, what kind of compound you can obtain? That is the question. So correct answer will be 3. In 3, what you can find chromium, which is complexed with BO2 taken thrice, being it is tripositive oxidation state around the central chromium, we can write a BO2 taken thrice, because BO2, each BO2 is accomplished with a -1 charge, so that we have to go for a 3 moles, means a 3 number of BO2, so that CrBO2 taken thrice can be mentioned. Let's see how can we write the entire reaction over here. So here what they are saying, borax. Borax stands for Na2B4O7 10H2O. Sodium borate decahydrate. 10 is called, 10 denotes what, deca, and it is the water, no? So that sodium borate decahydrate is called borate. Upon heating, what you can remove? Whenever heated, water will be evaporated. Whenever water evaporated, anhydrous borate will left. That is called Na2B4O7. Anhydride borate, we are not stopping over there. Rather, we are continuing heating. Whenever it is continued for heating further, so that it will be decomposed. Now it is the process called decomposition. The step number one is called dehydration. Why we are saying dehydration? Where you are escaping, where we are removing water, no? So that we can say step one heating is called a dehydration. Step two heating is called decomposition. Decomposition stands for any compound will departed, right? So you can find the NaBO2 plus B2O3, right? So here whatever B2O3 is generated, that B2O3 now treated with the chromium complex, chromium oxide, we can say Cr2O3 is called what? Chromium oxide. Whenever both are treated upon elevated temperature conditions, you can get the compound BO2 taken thrice. So here 2 moles of B2 we have, so that Cr2 also there, so that you can put the 2 as the coefficient, so that perfectly balanced equation we can get, and whatever compound generated is existing in a green color. So borax B test is distinguishable test for chromium. So whenever chromium is treated with borax B test, so that green coloration due to what? Chromium boron oxide complexation. This is the way we can answer. Question number 4, option 3 is the correct answer. Move on to question number 5. Question number 5 is collected from organic chemistry. We can say reagent chemistry, right? The major product formed in the following asymmetric synthesis. Okay. Asymmetric synthesis is nothing but any compound is said to be asymmetric where two poles are having different orientation, different composition, different kind of conformations, right? That is called asymmetric synthesis. If you are taking similar kind of reagent or a similar kind of starting material, then symmetry will be existing. But the compound what we are taking is starting material is different in orientation, different in composition, both edges. And whatever reagent we are taking is also not symmetrical. One side we have methyl and the other side we have bromo. So that reagent is asymmetrical, starting material is asymmetrical. It is said to be what? Asymmetric synthesis. And moreover, it is the reaction said to be Grignard reagent, reaction of Grignard reagent upon ketones. This is the kind of compound. You can see Sahar's representation, Sahar's projection it will be. But it is a truly astic model. All are inclined in certain angle in order to minimize the steric hindrance, right? Here is the ketone, and the second carbon you can find hydrogen, chloro, pH. And methyl magnesium bromide is called RMGX. RMGX is the general representation of Grignard reagent, where R is equal to methyl, Mg means magnesium metal, X means here we are taking bromide, so that it is more efficient Grignard reagent for reaction with the various. It is the most important reagent for the synthesis of multiple components in the laboratory platform, right? So organic synthesis mostly a new compound, the transformation is carried by Grignard reagent. Whatever compound you need, that almost is synthesized by Grignard reagent by taking a suitable starting material. That many applications you can find. Okay, so and subsequent hydrolysis is also required. And here the condition for carbonyl compounds to react with Grignard reagent is whenever primary in order to receive primary hydroxy compounds can be achieved by taking starting material, that is formaldehyde. Formaldehyde stands for HCHO. Whenever HCHO is treated with the kind of Grignard reagent, so that whatever compound obtained is a primary hydroxy. Whenever ketone is taken and again treated with Grignard reagent, the compulsory condition you will get tertiary. Whenever aldehyde other than formaldehyde, this formaldehyde gives a primary. So any aldehyde you are taking, that will be treated with Grignard reagent and final compound must be secondary alcohol. Let me sum up all the requirements for the preparation of various hydroxy. Whenever you are taking formaldehyde and treated with the Grignard reagent methyl magnesium bromide, primary hydroxy will be generated. Any aldehyde upon treating with Grignard reagent gives a secondary hydroxy, and ketone upon treating with Grignard will give tertiary. Is this ketone? Absolutely. R, C double bond O, R if present, that is called a ketone. That's the reason why we will get a tertiary hydroxy. So here you can find tertiary. Here also tertiary is located. Here also, here this is no way related with that one. OH is absent so that you can cancel out. And even option 4, you can cancel out. Why we need to cancel out? OH is not there. OH is the requirement product by Grignard reaction. So that third, fourth options blindly you can cancel out. And only the competition between what? OH left side, OH right side. Then why we are saying there is a competition? Because either of the position it can occupy conveniently. Anyone is coming, so he can occupy any of the position. But the thing is, we need to minimize the repulsions. Wherever we are staying, that minimum repulsion should be there. More stability we can acquire. Fine. So that what is the competing factor? Competing factor is the chloride over here. Whenever chloride is present, chloride always halogen is accompanied by 3 lone pair of electrons. Or any halide if you are taking either fluoro, chloro, bromo, iodo, that can be occupied with them. So how the Wi-Fi is surrounding by chloro is also surrounded with the lone pair of electrons in the entire sphere. That's the reason why even OH is also having 2 lone pairs. So 3 lone pairs and chloro, 2 lone pairs and hydroxy, so that they will make fighting. So it is not yet all preferable. Both are highly repelled. Both are having lone pair repulsions in the maximum extent, so that it not yet all suitable. And only the provision you can place chloro one side, hydroxy one side, far apart, minimum repulsions, maximum stability, so that compound one is more suitable for this kind of ketone to achieve the hydroxy, tertiary hydroxy compound. Let me show the entire reaction in a clear way. Whenever this ketone is treated with the Grignard reagent, so that ketone will be turned into what? OH and the C. One side, wherever oxygen is there, that will be turned into OH. And wherever carbon is there, that carbon is occupying this methyl. Methyl is connected with this carbonylic carbon, so that you can find a major product in this manner. It can be clearly represented in the Sahar's projection. Sahar's means one ball representation, one stick representation. Ball means backside carbon, stick means front side carbon. Fine. So this is the way we can clearly see ball and stick model called Sahar's representation, where OH and chloro are far apart, repulsions are minimized, stability is maximized. This is the way we can answer, because whenever any reaction carried so many components come into picture, we have to go for the suitability of conditions to react, feasibility of reaction between reactant and the reagent what we are treating, and the product. In what path it is driving, in what path it is moving to reach out the products, and after getting the product, whether all the forces of repulsions got minimized or not. So all these conditions plays a role in order to achieve the product. So finally we got the product which is having the orientation in this manner, and that is available in the option number 1. For question number 5, option 1 is the correct answer. Move on to question number 6, last question of the session. It is also collected from Telangana Gurukulam Degree College Entrance Examination. The product formed in the following reaction is... Okay, so if you see this arrow, there are so many components are written. What we felt, we need to go for series of reactions, so that it is very difficult to solve this question, so that we can skip. That is not the thing. Only the thing is, it is one step reaction only. Among all these, only one is the reagent, and the rest all the things are conditions for the reaction only. Okay, so that's the reason why whenever we are attempting the question, we need to go for reading the question twice, then only we have to answer that one, right? The compound what we are taking, pH, CH, double bond, CH2. This is called what? Styrene. Okay, So pH for what? Phenyl. So you can put simply benzene over there. Upon benzene, you can find a CH double bond CH2. So benzene with CH2 is called what? Styrene. The styrene is treated with phenyl double bond NTS. This TS is the protecting group for amine. So wherever amine is there on amine, you can place this tosyl. TS for what? Tosyl group. So it is the condensed product. So pH double bond NTS is the reagent what we are treating here. And CH3CN is called what? Acetonitrile. CH3CN is called acetonitrile. Acetonitrile is the not reagent, rather it is the solvent. We have to distinguish which is reacting, which is facilitating the reaction. There is a lot of difference between the reagent and the solvent. The purpose of solvent to dissolve the components in that, not to react with that one. And this is the reagent sorry, which actually participating in the reaction. So we have to distinguish which is the reacting one, which is the dissolving solvent, and what condition we are maintaining. 25 degrees centigrade, simply what? Room temperature conditions to be employed, right? So here 5%, 5 mole percent copper O2 taken twice can be taken. This is simply said to be what? Catalyst. Again, don't get confused about this one. So if any metal complexes are given, we can simply assume, not always, but in most of the cases, we can assume they might be catalyst, because the transition metal complexes, most of the compounds are said to be catalyst in the synthetic organic chemistry. So that it is the kind of catalyst. But only the our focus should be upon this styrene double bond and this double bond NTS part. Okay, so in order to achieve the product, we have to go for a mechanism. If you observe the mechanism, so that we can accomplish the product, the expected product will be our tricyclic ring system with the nitrogen. This is said to be heterocyclic compound. Heterocyclic compound only, right? So any ring system with the heteroatoms, only 3 possible heteroatoms we can found in nature: nitrogen, oxygen, sulfur, right? Here, this is the heterocyclic found nitrogen heteroatom. So let's see the mechanism. I bifurcated the reaction mechanism into 2 steps. In the step 1, I prepared the intermediate. The intermediate, whatever synthesized, can be reacting with the double bond over there. Now, the interesting reaction mechanism we will look into, where I'm taking phenyl double bond NTS. Okay, so this N denotes what? Nitrogen. TS for tosyl. Whenever this is the case, under solvent conditions, this is called acetonitrile solvent, we are dissolving in this, maintaining room temperature 25 degrees, need not to heat this, and one catalyst is added. In order to get the reaction faster, catalyst role plays a vital, right? So here copper catalyst was added over, so that bond broken, double bond homolytically cleaved. Homolytic means what? We are not getting any excess, rather we are sharing by breaking, right? So that we will get tosyl nitrogen. Actually, nitrogen always in general contains one lone pair, but after this we got another lone pair extra. So that whenever nitrogen is accompanied by 2 lone pair of electrons, that is called an intermediate called nitrene. Nitrene intermediate found. Nitrene intermediate is accompanied by the TS, right? That's why I mentioned tosyl nitrene as an intermediate. Okay, and one more thing I forgot over there. On this nitrene, one lone pair is there, one vacant site also present. Vacant means empty orbital will be there. Okay, that's the reason why we can say always carbenes, nitrines, all are said to be what? Amphiphiles. Amphiphile means what? This is a new term we can say. Electrophile is known, nucleophile is known, amphiphile is the both. Electrophile means what? Electron deficient in nature, and wherever electrons are there, it will grab. And nucleophile means what? Electron rich in nature, that used to give the electrons. But amphiphile means it having tendency to release the electrons, and at the same time it having tendency to accept the electrons. Any substance itself, it gain the electrons, itself, it donate the electrons dual property present, that is called amphiphile. Here nitrine is having lone pair, so that it will release, it will donate, and one vacant orbital will be there that will accept the electron. That's why if you observe clearly in step 2, two arrows are there. Arrow is inclined towards nitrine, that means it is taking up the electrons, and arrow is coming, that means starting from the nitrine, lone pair is given to the double bond. That's the reason why we can say nitrine is the part of what? Amphiphile, giving electrons, taking electrons as well. Whenever electrons are given, so that a new bond will be generated. Whenever electrons are taken, again new bond will be generated, so that we will get a tricyclic ring system with the nitrogen over there. Already we have a tosyl substitution upon, and one side chain will be there, that is phenyl. This is the way we can answer, which is clearly available in the option number 2. By this, we entirely completed the session, and we covered with the various dimensions of chemistry, where you covered with the physical chemistry part, analytical part is there, organic chemistry part mentioned, coordination compounds covered over there, and a detailed discussion with the evidences, with the detailed mechanism and the probable products. Everything got covered over there, and the session will be definitely informative if you are seriously observing and following the session what we are discussing over there. Hence, I'm sincerely requesting to like the channel, comment which is the important part for you, and share with the aspirants who are serious about the preparation towards the examination, either entrance or competitive exam as well. Subscribe the channel to receive more such updates in the near future. We are going to get a series of sessions in coming future. That's the reason why the channel called World of Competitive Chemistry is having the ocean of chemistry over there. Whatever you're searching, everything is available in the path of competitiveness. Okay, whatever examination you're aspiring, everything, every concept is available, because every day we are adding new things over there, so that you can find each and every concept related with the chemistry in terms of competitive spirit on this channel, right? Thank you very much for your patient listening. Thank you, one and all.